All right. Hey guys, this is Mrs. Lyons, and I just want to go over your quiz real quick so that you can make some corrections and get your points back and understand why you missed the things that you did. All right. So just this matching. When heat energy is added, the speed of the molecules increases. All right. Heat always speeds things up. Stored energy in chemical bonds is chemical potential energy. It's potential because it's in the bonds and it's released when those bonds are when those bonds are formed. So it's stored in the bond. The study of the heat. In other words, what are we studying in this unit? We're studying thermochemistry. When two objects are the same temperature, we call that equilibrium. The amount of heat required to raise the temperature of 1 gram of substance by 1 degree Celsius is specific heat. The type of energy that flows from warmer to cooler objects. Some of you put exo or endothermic for this answer. And basically, energy, this kind of energy, and this kind of energy is heat. Heat always flows from warm to cold, okay? Endothermic is when energy is being absorbed by the system. Exothermic is when it's being released. So energy always flows from warmer to colder, whether it's going from the system to the surroundings or the surroundings to the system. And then finally, the type of reaction where energy is absorbed should be endothermic. Okay. On the bottom, I wasn't very creative. As I was making my key, I realized that I want every other one. So if energy is on the reactant side, that is endo. If energy is on the product side, that is exo. Energy absorbed is endo. We have heat on the product side, that is exo. Delta H is positive, that's endo. Energy is released, exo. Reaction vessel feels cold to the touch. So in other words, when you touch it, the heat is flowing from your fingers into the test tube or the beaker. So this is going to be endo. And then reactants equal products plus heat. So heat is on the product side. That's going to be exo. All right. All right. So now let's get down to the calculations. And some of these were kind of tricky, I will admit. All right, so convert 600 calories to kilojoules. Okay, now, hopefully you realize that I put this over here. So your conversion is 1 calorie is equal to 4.18 joules. Okay, so we're going to use that 1 calorie is 4.18 joules. Okay, now that's going to give us joules. We need kilojoules. Okay, and this was also something a lot of you missed. There are 1,000 joules in 1 kilojoule. A lot of you confuse that and put 1,000 kilojoules in 1 joule. Okay, all right, so we've got 600 times 4.18 divided by 1,000 is 0.2508. Look at this and make sure. Now, what did I do? Now I'm questioning. Oh, I put 60. I did a calculator error. 600 times 4.18 divided by 1,000 is 2.508. All right. That's why it's so important to show your work, because then if you make a silly calculator error, it won't kill you or your grade. All right. How much heat in kilojoules is needed to raise the temperature of 236 grams of silver from 8.5 to 34.9 degrees Celsius? The specific heat of silver is 0.24 joules per gram degree Celsius. Okay, so this is where we're going to use Q is equal to mass times specific heat times change in temperature. Okay, it's asking us to find heat. okay? It's telling us the mass is 236. The specific heat is 0.24, and then we can calculate the delta T. So Q is equal to 236 grams times 0.24 joules per gram degree Celsius. And then our delta T is 34.9 minus 8.5 degrees Celsius. Now I want to show you something, okay? We didn't really talk about this, but your units are going to cancel out. So grams cancel, degrees Celsius cancels, okay? Because both of these are essentially over 1 if we wanted them to be fractions, okay? Which leaves us with our answer in joules. So let's do this. 236 times 0.24 times 34.9. Notice I have parentheses, minus 8.5 equals 14. So let's write this down. 1495.296. Notice what my units are. My units are joules. Look at what the question is asking. The question is asking you for kilojoules, okay? So I have one more conversion I need to do. 1,000 joules is 1 kilojoule, okay? So I'm going to divide my answer by 1,000. And that gives me 1.495296. So let's see, how many sig figs can I use? I can use 3 because I can use the ones, remember sig figs for when we do addition, subtraction, we'd have 34.9 minus 8.5. So that would be 14 minus 8 is 6, 26.4. That has 3 sig figs. So our answer can have 3 sig figs. So our answer is going to be 1.49 would round up. So that's going to be 1.50 times 10 to the first. Is that right? Oh, wait, I don't need, never mind. It's just going to be 1.50. Sometimes I overthink things. So it's going to be 1.5 because my answer is 1.495. So I would round up. That would give me 1.5. 3 sig figs is going to be 1.50. All right. Okay, this one was tricky. Okay. This one had a couple of things in it. First of all, our energy is given to us in kilojoules. Okay. So let's just right from the get-go, let's convert our kilojoules to joules. And the reason that we have to do that, I gave you the heat capacity, specific heat of water, and I told you it's 4.18 joules per gram degree Celsius. So in order to use that, we have to have units of joules, okay? So we're going to convert 1 kilojoule is 1,000 joules. So 12.15 times 1,000. I could have just moved my decimal place, but I get 12,150 joules. Now that's my Q. All right. Let's see, what else do I have? I have my mass is 475, and I have my temperature initial. Okay, so if I plug these things into my equation, Q equals MC delta T, Q is 12,150 joules, and that's going to equal M, so 4.7 or 475 grams, times C, so 4.18 joules per gram degree Celsius, okay? And then times delta T. So there's a couple of ways you could do this. You could solve for delta T, but I tend to do this. I put in my T final. So T final is what I'm looking for, minus T initial. Okay, now I need another piece of paper. I didn't leave myself enough room. So I've got this equation here. What I'm going to do, so let me rewrite this. So 12,150 joules is equal to 475 grams times 4.18 joules per gram degrees Celsius times T final minus 20.5 degrees Celsius. Okay, so what I'm going to do, I'm going to divide both sides of my equation by 475. Okay, so 12,150 divided by 475 equals 25. I'm going to carry some digits out, so 25.57894. So these cancel. All right, now that's going to equal 4.18 joules per gram degrees Celsius times T final minus 20.5 degrees Celsius. All right, now I'm going to divide both sides by my specific heat, so 4.18. Okay, so this gives me, if I do 25 divided by 4.18, I get 6.11936.5. Okay, now if I look at this, what have I done? So now I have this number, and that's going to equal, so this cancels out. What I have left is T final minus T initial, which is 20.5. So now I can add 20.5 to each side of the equation. Okay, so if I add 20.5, I get 26.6 degrees Celsius as my temperature final. Okay, so that was a little bit tricky. Some of you did fine. You converted from kilojoules to joules without issue, but then it came to the algebra. And you've got to be able to isolate variables in order to be 100% positive that you're going to get this right. Okay, your units will also cancel out. I didn't carry that through, but you could use your units to guide you. So this answer is going to be minus 26.6 degrees Celsius is your final temperature. All right, last two. Oops. These are thermostoic. This one is actually a limiting reactant. Okay, so how much energy will be given off in the following reaction if 3 grams of sodium reacts with 1.2 grams of nitrogen? Notice nitrogen is N2. Okay, so I have to figure out the energy for both of these starting amount of grams. Okay, so grams to moles. All right, so moles is going to be 1 mole of sodium. We need the molar mass from the periodic table. That's 22.99 grams. Okay, so our grams cancel out. Now we need moles of sodium. This is going to come from our balanced chemical equation. So 2 moles of sodium will produce negative 42.7 kilojoules. Okay, so that's the difference in doing stoic with thermochemistry, is we use that delta H. Okay, so let's see what we get. 3 divided by 22.99 times negative 42.7 gives us negative, did I do that right? Why is my answer, hold on a minute. Oh, I know what I did. I didn't divide. All right, try that again. 3 divided by 22.99 times negative 42.7 divided by 2. There we go. 2.78. How many sig figs? I can only have 2 sig figs, so I'm going to say 2 negative 2.8, and my units are kilojoules. All right. Here I have 1.2 grams of N2, so I should know 1 mole of N2 has a molar mass of 28.02 grams. All right. And then I have the same thing. I've got to look up here. I have 3 moles of N2 and the same delta H minus 42.7 kilojoules. So if I do this math, 1.2 divided by 28.02 times negative 42.7 divided by 3. Whoops. This is why I tell you guys always show your work, because if you push the wrong button, I can see what you're doing. I don't have to take away all of your points. There we go. That's not right either. I divided by 2, didn't I? Oh my goodness. Divided by 28.02 times negative 42.7 divided by 3.6095. So I'm going to round that to negative 0.61 kilojoules. Okay, so this is given off. You want the smaller, so 0.61 kilojoules is given off. Okay, one more. How many moles of nitrogen gas are produced from the following reaction when 275 kilojoules of energy is given off? So this is not a limiting reactant. You're just going from kilojoules to moles. All right, so 275 kilojoules. Then we just need what our information is from our balanced chemical equation. So kilojoules is minus 1530. And how many moles of nitrogen? So 2 moles from our balanced chemical equation. And do you know what I forgot? And I always forget. This says it's energy given off. Delta H is negative. If it's given off, our starting number has to be negative. And I'm going to talk about that in just a minute. It's not really a workaround, but it's if you think about your answers, I can save you from getting it wrong. All right, so I get 0.359. So let's see, I can have 3 sig figs, so 0.359 moles. Now, let's say I went through this problem and I didn't think about this negative sign, and I came out with a negative number. Okay, this is where you've got to just think about it. Don't just write your answer. Don't just plug it in your calculator and write it down. Think about it. Okay, our units are moles. All right, can we have negative moles? The answer to that is no, we cannot. Okay, we can't have negative moles. We cannot have negative grams. Okay, so if you get an answer, look at your units and make sure that it makes sense. Okay, all right, so hopefully this video was helpful and you can kind of see where you had things on your quiz that weren't quite right. And let me close this video.